126, 111, 148, 205, 198, 195, 225, 174, 175, 103, 227, 167, 155, 158, and 133. All right, so here are our data points. What we want to do is we want to find our quartiles. All right, well, if we're going to find our quartiles, what do we need to do with this data that we have? Okay, so the first thing we have to do is we have to list or order the data from least to greatest. Okay, so step one, we have to rearrange our data so that we're given it in a least to greatest fashion. All right, well, let's start doing that. What's the smallest value we have? 103. Okay, so 103 is our first one. Then what? 111. Then what? So I'll cross these off. How much? 126? 20. Okay, then what? 31. Then what?
133.
33. Then what?
148.
148. 155. 67. Then what?
167.
158.
158.
Alright. Then what?
167.
167. Okay.
174.
174. Alright.
175.
175. Alright.
195.
195.
198.
198. 205.
225.
225. Good job. 227. All right.
Good job.
So there we go. We have our data listed from least to greatest. Now what? Well, now we have the option of doing a couple of things. Okay. We have our data listed from least to greatest. Now, our goal here is to split this list of data into 4 equal groups where there's the same percentage of data within each group. Okay? So step 2. Typically what happens next is we find the median. Okay. Why do we find the median next? Well, because remember the median is the value that splits the data into half. Half above, half below. It's the easiest, oftentimes, it's the easiest one to find after we list our data. All right? In this case, the median is going to occur at the halfway point. Well, how many data values do I have? 16. Where's the halfway point? The halfway point is going to be in between the 8th and the 9th value, which in this case ends up right here. So our median is going to be that line right there. Find the median, we take the mean of the 2 values we have. So this is our Q2, or median value. And if you calculate that, what is it?
162.5.
In this case, it's 162.5. All right, so we found Q2. Now we need to find the other 2 quartiles. This is no different than what we just did here. Finding the first quartile means doing what? First quartile represents the lower 25%, right? Well, this is the lower 50%. Where's the lower 25%? The lower 25% is going to be the halfway point of the lower 50%. So here, our Q3, or our Q1, sorry, is going to be the median, or the halfway point of our lower 50%. In this case, it ends up being 132. Right? So we have Q3. Do the same thing here for Q3. Again, Q3 is going to be the halfway point of this collection of data, which again is going to occur right there. That ends up being 196.5. And there are our 3 quartiles. Okay. Process-wise is not any different than finding the median. All right, so those are our quartiles for this one. Okay. Now, if I was to ask you to sort of give me a description of how this data is spread out. Okay. Again, remember, when we're given a collection of data, one of the things we like to do is we like to talk about the shape of the data. Can we identify what the shape of this data looks like from this information that we have right here? Well, it turns out that we can, and we can do it in sort of a meaningful way, right? Let's take a look at, again, what these values are telling us. Okay? First value here, 25% of my data is lower than 132 pounds. 50% of my data is lower than 162.5 pounds. 75% is less than 196 pounds, and 25% is greater than 196 pounds. All right, well, 50% of my data, or 25% of my data lies in this range, and 25% of my data lies in this range, right? What's the difference between Q3 and Q2? How many pounds differences are there? 34 pounds. How much difference is there between Q2 and Q1?
30.5.
About 30.5 pounds, right? Those are roughly the same amount, right? Roughly the same amount from Q1 to Q2 as there is from Q2 to Q3. All right. Well, now let's take a look at the lowest and the difference between the smallest value and Q1. What's the distance there?
29.
About 29. What about the distance here?
33.9. Or 30.
About 30.5 here. So roughly we're looking at the distance here is the same as the distance here. That sort of should be telling us that our graph, hopefully, if we were to go through and do this, will have a rough symmetric shape to it. We're going to have a rough symmetric shape to it. The biggest reason why is because the distances here are roughly the same. That means that the middle spread of our data is pretty even on both sides of our mean. All right? Or our median, sorry. There's our Q2. There's our Q1. There's our Q3. So we can use these quartiles to sort of identify what the overall shape is by looking at how spread out the data is within each one of these various regions. In this case, our data is pretty evenly spread in each region. Okay? That should tell us that we're looking at a graph that's roughly symmetric. Okay? This rough symmetric shape. All right, let's take a look at another one. Slightly different. This time we're looking at heights, not as people in this class, but I was at basketball team some time. Height 72 inches, 74, 74, 65, 71, 69, 65, 62, 70, and 71. Okay. So here again, what I want to do is I want to find the quartiles, and I want to describe the distribution. All right. So first things first, we need to find our quartiles. Step one again, we need to list our data in order. Okay. So I will attempt to do that. If I screw up, let me know. that should be the ordering that you get here. Right? Sure, why not? Great. All right, first things first. Let's find the median of this data. Where's our median? What value is the median in this case?
70.5.
In this case, our median is going to be the halfway point, which splits, so our median would occur right there. Q2 is 70.5. All right. Okay, now let's find Q1 and Q3. Q1 in this case is our 65. And our Q3?
72.
72. All right. Now again, I want to be able to sort of describe the shape of the data like I have here. If I was to graph this, if I was to have a nice picture graph like the one here at the other side, if I was to draw a nice picture that represents the shape here, what would that picture look like?
It's skewed
To the which way?
to the right.
To the which way? Left. Okay. All right, again, we're looking at sort of how much data is in each of these different regions. Well, I know the percentage of data, but what I want to look at is I want to look at the data values themselves. Here, what I notice, the difference between Q2 and Q1 is about 5.5. The difference between Q2 and Q3 is only 1.5. All right? What about the distance down here? Well, down here I'm going another 3 units to get to the very bottom. Up there, I'm only having to go 2 more units to get to the top. All right. Now, let's think about this back in terms of percentages of data and where it shows up. 50% of my data is between 70.5 and 74 inches. That's a large percentage of my data in a very small, compact range. Okay? In terms of my shape, that means I'm going to have a big bump starting at 70.5 and going out to 74. Okay? So a lot of my data is concentrated down here on this side. Okay? Then the rest of my data, 50% of it has to start at 70 and go all the way down to 62. Well, again, I can have a very narrow bit, but just have it go out very far like that. Okay? 50% of my data is over here, so 50% here. And then the other 50% shows up down here. And I can see now that I have a graph whose left-hand tail has been pulled out farther from the median, or from the mean in this case, than the other portion of the data. And so here we have a skewed left distribution. And again, what we're doing is we're using our quartiles to sort of describe how that shape comes about. All right. So, what else can we do with this? Ah, yes. We've talked about using these measures of position. We can also use these quartiles to talk about how spread out our data is. And when doing spread with the quartiles, we use what's called the interquartile range. Interquartile range. This again, this is just another tool that we can use to talk about how spread out our data is. And in this case, the interquartile range is just the difference between Q3 and Q1. That's what the interquartile range is. Abbreviation-wise, the book and I will both refer to it as the IQI. And again, it's just a way of measuring the spread of the middle 50% of our data. That's what this measures. How spread out the middle 50% of our data is. Okay? Now you may ask, okay, well, why would I ever want to use this when I have all these other ways of measuring spread? Well, again, being able to identify how to describe the data